Okay, it's working for both. So we have two solutions here. Number 8, we're given an equation. S equals 4,000, 1 plus R, where R is rate, to the 5th. And of course it reminds us of what these things mean. Rate R as a percent that gives the future value, tells us the future value. In the beginning it tells us it's compounded annually, all that stuff. So you guys know that given something compounding annually for 5 years, knowing the future value and the starting value being $4,000, you know that you also are able to use your calculator under the alpha button and go in there to solve this problem without even having to deal with the actual algebra part of this. But let's work through the algebra anyway. So what this is trying to tell us is, hey, we have a future value, an S value here, of 5,610.21. And it wants us to solve for the rate. The first thing I'm going to do here to get R alone is I'm going to divide by 4,000 on both sides. So let's see, I get approximately that on the left, 1.42022 excuse me, equals 1 plus R to the 5th. I still want inside to that R, so I'm going to take the 5th root to get rid of that 5th power. Since it's an odd root, I don't have to put plus or minus, I just literally write 5th root on both sides, cancel it. In the calculator again, I'll hit 5, math, I will choose number 5, which is the X with the root symbol. And then I'm going to put the number under there. Or actually, better yet, since in the memory of my calculator I have a more accurate version of that number, I'm going to hit second answer, which is over my minus key, here at the bottom of the calculator, and then enter. So I'm getting 1.07, 1 7/100. So I have approximately 1.07 is equal to 1 plus R. Now to solve for R, I'll subtract 1, and I'm getting 0.7 equals R. And it wants us to find it to the nearest whole percent. So I'll move my decimal 2 places to the right, and I'll say the rate is approximately 7%. So 7% is the answer for number 8. Again, remember guys that if you go into your calculator and you hit the apps button, let me make some notes here in the margin for you. Go into Finance and the TVN Solver, you can do the exact same thing, where we know that something is being compounded 1 time a year, so 1 times 5 years. There's a 5 in there for my capital N. We don't know the interest, I'll put a 0 and come back to that. We do know the present value started off at 4,000. The payment, let's see, so interest equals, we left that blank. For present value, we put in 4,000. For payment, there was no payment, so we put a 0 that we're actually going to leave there. Future value, we know the interest rate gave it a future value of, after it compounded all that time, let's see, $5,610.21. Then we tell it it's compounding once per year. So now I'll go to my interest rate, alpha solve. Oops, I've got to change my signs. It's actually yelling at me because it wants one of these to be negative. So I'll put in negative 4,000, since I really just try to ignore that. The idea that it likes the present and the future to be opposite. So again, I'll hit alpha solve, and I get the same thing, 7%. So you actually have 2 not difficult ways to do that problem. Down here on number 9, that should actually be a pretty quick problem. It says use synthetic division to find the quotient and the remainder. So remember that synthetic division, you still need to have your terms prepped where you count down 3, 2, 1, none with your x values. And it specifically works for things where you have just a plain x plus or minus a number. Then what you do is you take the opposite of that number. So I've got a negative 1. I'll put it over here on the left. And I'll represent every term just by its coefficients. So I get a 2, a 3, a 4, and a negative 10. Draw my line, drop down my 2. And then the process is actually very quick. I say 2 times negative 1, that gives me a negative 2. Put those together, 3 minus 2 is 1. 1 times negative 1 is negative 1. A 4 minus a 1 is a 3. 3 times negative 1 is negative 3. So that gives me a negative 13. And on this thing, since the degree was 3, x cubed, we know that with synthetic division, we always take 1 away from the highest power. So I'll start off with x squared, count down to an x, then nothing. And the last piece is always my remainder, which I put over the x plus 1, the piece that I was dividing in. So my answer then over here is 2x squared plus x plus 3 plus, or and the remainder was negative 13 over x plus 1. Number 10. We're given a polynomial, and it just asks if x plus 5 is a factor of the first polynomial. There's a few ways to do this. The main way that we have explored in this class is to either use long division or synthetic division, and we know that it's a factor if the remainder is equal to 0. Now, there's something else that I can add here for those of you who would like more information. That's the factor theorem, which is if I take the actual solution and I plug it in to my polynomial, I'll know if it's a factor or not if my polynomial is equal to 0. That means that the remainder would also be 0. So actually, excuse me, it's the remainder theorem. I'm sorry, I said the wrong name. But the idea is still the same. You would plug that factor in. First, let's use synthetic division since that's the main thing we used in class. And then we can go back and plug that in and check it the fast way. So I'm going to have, let's see, it counts down x cubed, x squared, x, no x. So I'll use my coefficients. 8, 37, negative 14, 5. Drop the 8 down. 8 times negative 5 is a negative 40. That's going to give me a negative 3. Negative 3 times negative 5 is a negative 15. So here I'm going to get a negative 29. Let's see, negative 29 times negative 5 is, let's make sure I didn't make a mistake here. Oh, I did make a mistake. Actually, right here we have negative 3 times negative 5 is a positive 15, giving me a 1 right here. 1 times negative 5 is negative 5, giving me a remainder of 0. So you have the answer here, but all you care about is the fact that your remainder is nothing. And again, for the answer, that would have been 8x squared minus 3x plus 1, remainder 0. You can also take your function, so 8, and plug in the negative 5 and see what you get for every x that you have. So when I plug in a negative 5 everywhere, I used my calculator to do this quickly. I get row here too, and again that's called the remainder theorem. So because this equals 0, it does tell me that's a factor. So you can use synthetic to get a remainder of 0. You can use the remainder theorem, or you can use long division, which, like the name kind of tells us, it's a little longer. But the idea is, remainder of 0 means yes, this x plus 5 is in fact a factor. So I'll say B. Remember in all of these that I had x plus 5, but what I was really testing was the answer negative 5. Remember how it's always the opposite? That's why I plugged in a negative 5 in the remainder theorem, and I also used a negative 5 in the synthetic. So I did switch that number there. Number 11 gives us one solution, the solution 4, And it asks us to go ahead and use synthetic division to find any remaining solutions. So to do that, I'm going to actually use synthetic division. I'll take the 4, which is the solution, and put it there. I've got the x's, oops, not completely in order. Actually, that'd be x cubed. There's no x squared, so I'll say plus 0x squared minus 12x minus 16 equals 0. So now that I've gotten this all in the right order, I'll use the coefficients of 1, 0, negative 12, negative 16. And again, since the solution was x equals 4, that would have corresponded to an x minus 4. So we are using the opposite. The solution is the opposite. That 4 is correct. So please make note of the fact that it's a little bit different between these two because we were given different things. So here the process is the same beyond that. Drop my 1. 1 times 4 is 4. Get a 4. 4 times 4 is 16. I'm going to get a 4 again. Another 16, and a remainder of 0, which is nice since we're trying to factor this thing by hand. In other words, from this right here, we know, let's see, 3 was the highest power, so it'll start at x squared, counting down to x and no x. So in other words, I know here that x minus 4 times x squared plus 4x plus 4 is one step into the factoring process for my original polynomial that was an x cubed. Now I can use regular factoring to do the last step, and of course I use grouping. So multiply, add. I'll say it multiplies to be a 4, adds to be a 4. Sounds like a 2 and a 2. So I'll actually do this last piece by hand by using 2x plus 2x. Sometimes when you're doing the algebra on this step, remember that you can get to a point where you can't factor by hand, whether you're using the trial and error method or whether you're using the grouping method, which I use. In that case, we still have the quadratic formula that we can use, or completing the square. Both of those are nice because they will give us imaginary solutions. So in the case that we cannot factor them, we'll still get nice solutions, whether they be decimal numbers or imaginaries. The quadratic formula is my personal favorite to go ahead and move beyond the point if I get stuck here. Let's see, but since this one's a pretty nice one, I have x times x plus 2 plus 2 times x plus 2. Now some of you all probably noted, and I'm always so slow at noticing this, that this was actually a perfectly square trinomial where I just have x plus 2 times x plus 2. So if you know those shortcuts, certainly implement those. Okay, right here we're going to get all the zeros. X equals 4, x equals negative 2, x equals negative 2. We don't have to write the same one twice, but a lot of times in the picture what we've started seeing is that whenever you get a repeating x value like this, usually it means that instead of your picture passing through the point, it's actually bumping off the point. So we know just from past experience that here if we were looking at a picture of this to check our work, we'd be expecting, let's see, the power of 3 is the highest, minus 1, that means 2 curves, where one of the curves goes through a positive 4 and the other curve bounces at a negative 2. We would also notice since that a is positive, the end behavior is pointing up. So as far as graphing this, we could actually almost sketch it by hand, but graphing it we should